We are honored to host Micheal Drapkin. He is the Executive Enterprise Architect for QCM Technologies, and he's going to walk us through what are containers and how can they impact your IT operations. So, Micheal, I'm going to turn it over to you.
Uh, Thank you. I fired up the camera. I don't know if that's a good thing or a bad thing, but thanks for everybody for joining. And yes, I am with QCM Technologies. I'm an enterprise architect and consultant at QCM. And the topic, we've talked about this topic internally a bunch and with customers. And I will probably be the 3006th YouTube video on what is a container. So I'm not trying to repeat or redo any of those kinds of things. There's lots of information out there if you feel the need to go explore. But the topic has been raised and people are a little unsure about it. So I thought we would dive in a little bit. And the topic is I call it run IT anywhere or run it anywhere because that's one of the value components one gains by containerization. So the main question people ask when we get into this, whoops, delays. We get into it is they ask what is a container, right? So when we have that conversation, I can't go down into what is a container without going back on some historical perspective on virtualization, the topic of virtualization. Now, I'm hoping as I go through this, there's a lot of you out there saying, yeah, been there, done that, understand that. That's fine. This is kind of foundational because we have to compare and contrast a little bit. So the word, according to Micheal, what is virtualization, right? So virtualization to me is, well, I boil it down to the phrase lying, right? That's when there's a piece of software somewhere that's lying to you about the things that you have. So in essence, it creates an abstraction layer. And virtualization is there to give you things that you think you have, even though if it's not exactly yours. The concept of virtualization has been around 50 plus years. It's not new. And in the 70s, mainframes before PCs were around used these techniques to stretch resources and provide isolation for rogue tasks and other things. So there are a number of mainframe operating systems that the letter V is in them, like VM and MVS and so on, where that V stood for virtualized. There's an old saying that I grew up hearing that said, if you can see it and it's there, it's real. If you can see it and it's not there, it's virtual. If you can't see it and it's not there, it's gone. So that's a bunch of IT humor. But anyway, it's just a common concept, right? That you want to do these things. And and another phrase I use is it may be shiny, but it's not new. Virtualization's been around a long time and it's ingrained in what we do every day. So how do you pull off virtualization? Traditionally, virtualization is done using a thing called hypervisors. And a hypervisor is the software layer that creates the virtual machine environment. It simulates native hardware. Now, I've seen that used to be able to get better utilization out of system resources by running a hypervisor, and instead of dedicating a piece of hardware to an operating system, I can now run multiple operating systems at the same time on the shared hardware, right? So I get economics by combining and sharing. I've also seen it used in development where, for example, chipsets were coming in the future. The electrical engineering side was still working on the chips, but the software development side couldn't wait for the chips to become available. So we had to simulate that chip stack and the instruction sets in software and create a virtualized computer or virtualized system whereby the developers could develop software for things that didn't exist yet. So virtualization is critical. It's been around a long time, but its idea is to create that the sharing of resources. And by the way, the resources, when they're shared, can be pooled. So like you could have a certain amount of memory dedicated to you, but you can grow into memory that's not being used by another process or something. So there's all kinds of ways to do that. And the hypervisor itself can run natively in on top of an existing OS, and or it can run in the microcode down in the hardware. So there's a number of ways that we've seen virtualization come to the market. An example of some of these hypervisors are things that we're familiar with, like VMware, Hyper-V, KVM. There's a list of some things. There's other things out there like Nutanix and Acropolis and other places where hyperconverged computing has used virtualization to get the density that they need. And in IBM hardware, the mainframe and the power systems have it running in the microcode called Power VM. And so all the operating systems by nature are all virtualized at the hardware layer. So you'll see it come up in a number of ways, and it's just an ingrained thing that's been going on. And so we're seeing that maturity probably in the last 20 years of people adopting virtualization as a standard pattern of doing things, right? Getting economic value and deploying stuff. And we have tools and skills wrapped all around that these days. So then we hear the word container and we say, well, what's that in contrast, right? So a container is in essence another virtualization technique, but it uses the underlying operating system's resources and namespaces. And we can talk a little bit about namespaces, but it basically shares elements of a single operating system. So now we've moved the virtualization up a bit to where we don't have multiple operating systems, but we do share and use the existing operating system, and we don't install in containers a complete operating system. We only install the operating components, the application program, and any dependencies that are uniquely needed for running that whatever it is that's in the container. And then we can map or share system resources that the operating system has and expose the internal things in the container to the outside world if we choose to. But it creates this environment where isolation is achieved between containers, but the resources that it's sharing is that of an existing operating system. So, by the way, I want to say as we go through this, if you have any questions, if there's anything I said causes concern or something, please post it in the chat. We're going to take a look at what you say over time. And if we want to turn this into a discussion, I'm all for that too. So the next concept of containers that makes them a little different from operating system virtualization is the term ephemeral. Now, I put it in here predominantly because I like the term. It's not something that a lot of people use on a daily basis, but what does ephemeral mean? And it means that and I put the Webster's link up there, it's something that lasts for a very short time period. So the concept here is that you can spin up a container to do something interesting and then decide you don't need it anymore and throw it away. And then spin it up again and throw it away. So they don't have to be running all the time, just when you need them. And so that construct differentiates this from VMs, where you have to boot up a virtual machine and then start the applications, and there's a time frame involved in doing that. Containers launch pretty quickly because you don't have to build the rest of the ecosystem just to run the container. And that lends itself to being able to be small, lightweight, and it makes it so that you can get it running and throw it away if you're not using it anymore. So that lends to I was just leading down the path of reusable, right? So way you build a container, and we'll talk about this in a second, is you create an image that has the things you need, and you spin up the services, the microservices, or the complete operating environment if you need it, as you need it, and you can use it in a lot of places. So once you've built it, this is part of the business value. Once you've built this function, and you have the ability to deploy it, you can deploy it multiple places. This is the run it everywhere, or run it anywhere you need it, right? I just have to get the container distributed to where I need it to run and throw it away when I'm not using it. The hybrid component, and hybrid in my definition is it lives because we get into this cloud terminology. Hybrid means to me that it can run in any place. There's a component you can leave on premise, and then there's a component that you might want to run in a cloud resource or a hosted resource someplace else. And the hybrid aspect of this is very cool because you can run the container anywhere you need it. You can run it on premise in your own environment. You can shove it off to a platform as a service environment that somebody's hosting for you. Or maybe you're building some cloud native workflow and you need a function stood up to support that. And it's not an either or, right? All of those things can be done at any time. So very, very cool in its portability. Um, now,
Um, uh,
yes, go
Michael,
ahead.
I hate to stop you when you're on a roll there, but it looks
No,
like
no, good.
we do have a question. Um, and I think you can possibly answer this. So, do
Uh-huh.
I have to transform everything into containers?
The answer is you do not have to. Containers are, in essence, a component, a function that you can stand up as you need it, and it can be in support of any other existing workflow or process. We'd have to figure out how to integrate it and how to deploy it where you need it. But it is not an either or by any means. And the transformation can be done in nibbles and steps. It does not have to be an all at once or boil the ocean kind of thing. Does that answer? Okay,
I believe so.
I believe so. Okay. And if that wasn't complete, let me know. The next part about it is from a business standpoint, we have to manage these things. So in order to figure out how do I manage containers, right? Because that's obviously an operational concern, a financial concern as well. Um, how do I manage these things? And so let's take you through a little bit of building a container. And this is not command line. This is not demo. This is whiteboardy kind of stuff. We can go as deep as you want on a separate call. We can get together anytime. But to start it out with the whiteboard view, I got this high-tech image. So the way you build a container is you create an image file, and that file is the packaging of an application, its code, Python or some other program you've got, and its dependencies. So a particular library or a particular version or something that you need to work with. And it may not be the thing that's running on the operating system or some other place, right? This may be useful for this function alone. Or the application you're standing up needs a particular release level of something. And you package those things into this thing called an image file. And then we take this image file and we put it in something called a repository. And that's a collection of images. And the analogy I use is if you got an iPhone or an Android phone, there's a Play Store or an iStore, Apple Store, and you'll see functions, if you will, living out in the Apple Store in a repository. And you can go out there and say, I want to run that. Now, you don't run it there. You grab a copy and you stand it up on your device, right? So in essence, that's not far off the way this kind of works as well. So you package up what is necessary, you put it in the repository, and anybody who's authorized to consume from that repository can grab that function and use it. And you can do it by issuing for a simple way on a simple computer, maybe my laptop. I might go issue a run command to stand up a container. And I'll do this. There are public repositories out there. I'll go find something interesting. I'll grab their image file and I'll stand it up on my laptop and I'll play with the container just to see something more about it. So I'll use a run command. If there's dependencies, other things like this application needs a particular database or needs some network service or something else, or I have to start it with these values like this user ID and password or these web server settings or something, I can define that and use a compose function, which is a method of orchestrating or scripting that. So we can manage that way using a set of tools, command line tools and others to help get this process under control. Now, along the lines of those construction basics, right? A container can be deployed within the on-prem environment again, or in the app service. Oops, excuse me. Mute that. Or as a service as part of some cloud native workflow. So you can do what we just talked about anywhere you need as well. So to deploy it, you might stand up a container as needed, right? And so here's a little view of um, how this might fit together. So you've got a Linux, say a Linux operating system, and then you install a container runtime. And that runtime environment is in essence analogous to kind of like the hypervisor you used elsewhere. It provides isolation between the other containers. And when you stand this up, the application container that's there might want to talk to the database container and maybe the web service container, or maybe only the DB and so on. So you can build these relationships, but what happens is there's a virtual network that's created that allows all those containers to talk to each other as needed, so that the app server can talk to the web server, can talk to the database. And it may be that you only want to expose the web server to the outside world. So no one from the outside can actually directly get to the application. They get there via the web service or something like that. And so it can be set up and orchestrated in a way that lets other content. I might not want to start this application server without the database server, for example. So we can set these things up that make sure that the containers dependencies are met as well. So this is a nice thing, but what about standardization, right? So there's lots of choices out there in the container space. And there is a thing called the Open Container Initiative. And the Open Container Initiative is an open set of standards that defines what images must look like or have, what containers must look like or have, how to distribute them, and so on. So there are standards. Now, an analogy I had for containers is it's kind of like your desires to go to the airport, right? And you can do that with your car, but maybe the container is kind of like the engine, and you go to the store, the repository, and you grab an engine, and you stand it up in your chassis frame, and you get the engine up and running, and you can put it on, you can take the container and run it on a stand, and you can look it over and evaluate it, and all that's really cool. That's the container, but it's not doing anything yet for you, right? So then you might want to put it into the car. And well, in order to make this car useful, maybe I have to connect in things like seats and doors and the rest of the body. Okay, that's fine. And maybe I need a dashboard and maybe an entertainment system. And it's possible that maybe the dashboard's another container and maybe the entertainment system's another container stood up. And then you package this all up and you can go drive down the road. And while you're driving down the road, you might decide that you don't like that dashboard. So you can stop the dashboard and spin up a different dashboard. You didn't affect the rest of the stuff, but you have this ability to compartmentalize and contain, if you will, functions and allow them to work with dependencies on each other, but also independent of each other. And this Open Container Initiative helps support that capability. So what is perhaps a business value, right? We can't just go do this because it's cool. I'm a big fan of cool toys and I like playing with cool toys, but sometimes that's just nice. It's great for the lab. But is there any business value associated with it? And I think one of the things that we see is that it helps with right sizing. All right. So in the hypervisor space where you stand up VM, for example, let's pick on VMware, and you put Windows out there and you run VMware on top of it, and then every virtual machine is running another instance of Windows or Linux or something, and that's just the way you do things. Well, it turns out that every one of those operating systems that you run has to have licensing associated with it, and every one of those operating systems now is exposed to security issues and patching requirements, and the costs of doing and delivering and monitoring and managing, right? And so the distinction is that with containers, I'm running it on a single OS. Now I might have a bunch of OSs, and in theory, those OSs could run inside a hypervisor. As a like in VMware could be hosting a Linux guest in which Docker is running as a container runtime. So you could do that stuff, but the idea is to get away from that, right? And just have to allow the patching and the maintenance of the underlying OS, and potentially the applications themselves, the components in the containers might be managed. But you now manage that in one place. You manage the image file, you manage that, and then you just push it out and replace what's out there. And so the very, very focused way and a lower cost way potentially of actually managing the changes that are necessary to keep the ecosystem going. You also have the ability, because you might have a container-based model, to generationally keep generations of image files around, and then roll back is a lot easier, right? So anyway, I think containers, one of the reasons they've been adopted over the last 10 years is they provide some level of enhanced optimization, and the cost model's probably a little better around managing these things. It can be that thousands of containers deployed, depending on the scale you're operating at, needs another set of tools to help manage it, but those exist too. So it can get squirrely, and we would want to start at the beginning and look at your roadmap and your direction and kind of start to figure that out as we go forward. So been talking about containers, been talking about some contrast with VMs and so on, but give me some examples, right, Michael? So in the example stack, I mean, I have things like the microservice architecture. If you're refactoring your traditional monolithic applications and you want to break it apart, because right now all you can do is lift the entire stack and move it someplace, but breaking it up gives you the flexibility and reusability. If you're going to do that, containers are a great place for hosting the microservices. It's also very helpful if your development environment is transitioning or using continuous integration, continuous deployment styles, because containers lend themselves to being stopped and started as a part of some bigger thing. So it gives you a consistent environment across both development, test, and production, and you can orchestrate within that pretty readily. It also handles the concept of hybrid and multi-cloud. Because it has a standards-based thing, you can run on-prem, in cloud, across multiple clouds, different cloud providers. And the same container, the same image file can be deployed wherever you need it. So it gives you this real flexible portability, and that is a real, I think, a cost advantage as well. So I'd be remiss if I didn't drive down just a little bit into the command line, and this is the lowest level I'll go, I promise. But some examples of commands one uses when working with a container. I picked Docker as the environment just because it could be something you stand up on your laptop or your Raspberry Pi or something to play with. You would issue things like a Docker pull. And you go out there, and what that does is it goes to the repository and grabs that image file and pulls it down to your machine. And then once you have the image file on your machine, you'd issue a Docker run command to stand it up and execute and create the container. And then you might decide you're done with it, and you can issue a Docker stop of the container and so on. And then you can create a YAML file to help build with the compose or orchestration. So just an example, these are kind of tools. And by the way, you can do this stuff easily on single board computers. You can do it on your laptop. I frequently have Docker running on my laptop, and I see something interesting and go play with it. So it doesn't have to be a big investment to get started and to kick the tires and start to look at it. So I see a question: what's the best use case for starting with containerization? Well, I will answer that by suggesting that perhaps it's the dev test guys, the development guys, that giving them a platform to start to develop code a little differently, and be able to get skilled in the art of containerization. I think the dev guys would be probably the right place to start with, and try to figure out start to learn how that fits into your development workflow. That's probably my guidance on that. Is development's a great place to start. Production will happen, but development is a great way to get comfortable with it. So a little more detailed discussion on tools and management, and I'm seeing a question: how easy or not easy is it to move or migrate a container from private to public cloud environment? It's incredibly easy depending on what target you're you're aiming at. So in essence, if you have access to the repository on-prem and the same repository in the cloud environment, all you do is do a pull of the image and start it wherever you want it. So very easy to do that. And then have that container instance instantiated wherever you need it. And to that end, I mean, we also have tools, right, wrapped around this. Uh, this isn't an on its own kind of thing, right? So there's stuff with managing this environment. We talk about managing not only the deployment of things, the running of things, but also the security of things. And there's a question about security permissions, follow the move. The security permissions are tied to the environment you're running it under. So you might inherit some of that depending, and I'll talk about some of those options in a sec. But I see the question is, if you move it, do you move it? I think what you don't do is pick it up and run it somewhere else. You actually start the container as part of the ecosystem in the other place, and it inherits whatever permissions you've built in the target location. So it's not a vMotion kind of move where you while it's running, you relocate it. I think you more likely start an instance in the other place and have your ecosystem find it. But under the tools and management pieces, there's a couple of different tool sets, right? So Docker is something people probably have heard. It came on the scene about 10, 12 years ago, and very popular, but it's kind of like the engine, right? It's the runtime environment. It gives you the place to run those things. And it has some repository capability. There's Docker Hub, and then there's Swarm, which is some deployment tools. It's great. It's a wonderful place to get started. It's a wonderful place to use. It has some great values. If you want to do more in the open source community, Kubernetes is there for doing more management of those containers and orchestration. And so I think the security policies and things might fall into using a tool like a Kubernetes to relocate a workflow and impart and ensure that the security needs follow it or are there where it lands. But Kubernetes is a thing, and you may see people walk around with a shirt that says K8S on it, right? And I find it interesting that if people see that and they associate K8S with Kubernetes, and the reason they do, and this is the secret decoder ring moment, is Kubernetes is a lot of letters. It's hard to spell. So to simplify it, it starts with a K, it ends with an S, and there's 8 letters in between. So K8S. And now you know, when you see it, they're talking Kubernetes. It's just letters in between. And then, of course, from an enterprise standpoint, Red Hat has spent a lot of time and money over the years embracing this as well and furthering it as part of their ecosystem. Red Hat OpenShift is indeed an enterprise-grade stack runtime. It has the runtime environment for containers. It has the repository. You can have your own private and public repositories. It's got all the deployment tools, performance monitoring, management, security things. So if you are really using this in production, probably a tool set like OpenShift might be very, very important to the success long term. It again, not required, but it does give you some knobs and some controls that they found important and have developed. Well, what can I do with that? I can do all those things as a platform as a service. I can get, for the car analogy, I could rent the car, right? And I get it as a service with the ability to put my engine in my dashboard and do whatever I want in it. Or if I wanted a as a service function where, say, I don't want to build my own OpenShift environment, I just want to worry about the containers, I can get something like OpenShift as a service or Kubernetes as a service. It's kind of like you can even get the Uber version, right? That says, build it and drive it for me. I just want the functions, right? So all of those things are doable, and it's doable on premise, in the cloud, on your laptop, on your Raspberry Pi, at AWS or IBM Cloud, wherever you want to run it. Integrations, and this goes to the moving, I think, as well, getting started. Do I have to boil the ocean? You don't. But integrations are embedded in the application environment where you're developing. You you have some components and integration both in the operational side. In other words, how do I integrate with other workflows, right? How do I go with costing tools that are watching um, spend on the cloud, right? All those things are there at some level, depending on the tool set you look for. But also the development operations. For example, if you have an IDE or development tool set that you use, these days, things like Docker is embedded in to some of the IDE environments or Java development environments or whatever, such that while the developer's in writing code, they can spin up a container to test the application while they're in the development environment. So it isn't just an on your own thing, it's integrated into development tools as well.